Hello, I'm Robert Arnason of the Western Producer, and this is Between the Rows. It's common knowledge that the age of a tree can be calculated by counting the number of rings. But scientists can decipher much more than age from the rings on trees. They can also tell how much rain fell in the past and what the climate was like hundreds of years ago. David Souchin is the director of the Tree Ring Lab at the University of Regina, and this fall he spoke with Geraldine Wichers, a reporter with the Manitoba Co-operator.
Well, there's trees in the foothills of the Rockies that are close to 1,000 years old.
But before we hear from Dave and Geraldine, scientists at the University of Saskatchewan are seeking an answer to a question that's also connected to weather and climate change. How much carbon is stored in pastureland across Saskatchewan? Angela Bedard-Hahn, a soil expert and dean of the College of Agriculture and Bioresources at the U of S, says scientists have never counted the amount of carbon sequestered in pasture and forage land in the province. So, she's leading a project to answer that question and also hopes to identify ranching practices that put more carbon back into the soil.
We understand that, yes, the carbon is constantly turning over, right? And so at any given point in time, what we're seeing in the soil is the net amount of carbon that's stored. There's constantly new carbon being put in, and microorganisms are constantly using that carbon for as part of the global biogeochemical cycles that they drive. So there is constant carbon turnover.
But before we hear from Angela, here's a word from our sponsor.
Maybe you've had an idea about upgrading your operation. Maybe about finally getting that renovation done or buying some new equipment. Or maybe you're thinking about how you can be a bit more financially secure from season to season. Get some help making it happen by speaking with an RBC Agriculture Account Manager. Then, set up an investment plan to make even more of your ideas happen. Visit rbc.com/chartyourcourse and get started today.
All right, back to my interview with Angela Bedard-Hahn of the University of Saskatchewan. Hi, Angela. Thanks for doing this. I really appreciate your time.
Great. Well, really happy to be here.
So, just to begin, can you provide us with an overview of the science around pastures and carbon, such as how do we know that pastures sequester more carbon than other crops?
Sure. Well, when we think about pastures, and most pastures are under perennial grasses, which is very similar to the grasslands that our soils developed under over the past several thousand years. And so those perennial grasses and forbs tend to have relatively deep roots, well-developed root structures, and those well-developed root structures tend to contribute a lot to the below-ground carbon storage. So the roots themselves, as they die and decompose, become part of the carbon pool, and they're also giving off root exudates as well, and they basically contribute to this rich microbial community in that rooting zone, and all of those things together combine to a really carbon-rich environment. Annual crops don't tend to have the same kind of root development, and with some of the other tillage practices, it means that the carbon tends to turn over a little bit more readily, particularly with our more intensive cultivation practices, less so with conservation tillage. So perennial pastures really get around a lot of that and allow for more carbon to be stored on an ongoing basis.
Okay. So just getting back to, first of all, thank you for that explanation. I appreciate that. But getting back to your research for a second, the press release for the research, which was released back in May, said, quote, "One of the outcomes of this project will be maps to provide an accurate estimate of carbon in Saskatchewan's pasture and rangelands." So simple question, how will you do that measurement?
So there's two components components to that, and so one of them is straight-ahead carbon sampling. But rather than sample every single field that's out there, we're going to use a combination of, we're basically using a sampling design that'll allow us to stratify the different regions of the prairies and look at soils with particular combinations of climate, management practice, and soil texture, all of which we know will influence the amount of carbon that's present. So from there, we will develop a sampling strategy that will go out and collect samples strategically within individual pastures, and we'll combine those samples that we take with predictive mapping techniques that will then allow us to more confidently scale up those results across a broader area. So that combination of very targeted sampling based on what we know about what influences soil carbon and how it's distributed across the landscape, with these predictive mapping techniques and machine learning algorithms that allow us to say, okay, it's reasonable for us to assume that if this is the carbon we found in this particular area, it's also reasonable for us to extrapolate that to these areas and these landscape positions under these management conditions.
So let's just look at one part of Saskatchewan, say like the northeast of Saskatchewan, which is, a little wetter, a little bit heavier soils. You could say, okay, this is what the data found in this area. And if there's another area which has like similar conditions, then you can sort of apply that to that area as well.
Exactly. So we won't measure every single pasture, but we will use tools to it that allow us to identify representative pastures. So then we can then extrapolate that to the ones with similar conditions. Exactly.
So as it stands right now, when scientists or researchers are trying to guess or estimate what we have or what kind of amount of carbon's in pastures, is there a data set that already exists? Like, has this been done before? I guess that's my question.
I really wish it had, but no, it's not something that's been done before. I mean, we have some samples that maybe going back to the original soil survey era, there might be some samples that were collected in pasture land, but we don't have that really good sense. And in particular, we don't have that data that will allow us to really scale it across Saskatchewan. And in particular, we don't have anything that really links it to, that allows us to make any kind of linkages to specific management practices. We could look at the older data and say, yeah, we know that that pasture tends to have more carbon than grasslands, but we don't know necessarily how well that translates to different management practices and different soil textures, different climate zones, in the same way that would allow us to really inform management strategies, beneficial management practices, or even policy for that matter.
All right, so just to jump onto that topic for a second. So if certain farmer or certain cattle producer or livestock producer in one region follows a set of practices, and then somebody else in a similar type soil zone does something differently, you're going to be comparing those two scenarios to see which one stores more carbon? Or I guess my short question is like you're going to be looking at the why part, like why more carbon here and less there. Is that correct?
Exactly. So we will be working with producers, first of all, to identify what suite of practices are appropriate in a particular region. So, going back to your Northeast example, right, something that works really well in the Northeast or is a norm for pasture management in the Northeast might not be at all relevant in the dry Southwest. And so we'll work with producers first and foremost to figure out what suite of management practice we should be looking at. And then, we'll be trying to normalize that, or basically get to the point where we can compare apples to apples in terms of management practices. So yes, given climate and texture X, which management practice, A or B, is more effective in terms of carbon storage.
All right. There was also another line in the press release that something you said actually caught my attention, was that one of the questions we don't really have a good answer to is like how long carbon stays in the soil. So, obviously there's a cycle where, it's used by plants and then it gets stored in the soil, sort of thing. Like, is that something that we actually understand at this point? Like, this is carbon, once you store it in the soil or sequester in the soil, there's something there that's there for 20 years, 30 years, 50 years? Like, do we have any understanding around that issue?
We do have some understanding around the issue. It's just figuring out what. So I guess to step that back, we understand that, yes, the carbon is constantly turning over, right? And so at any given point in time, what we're seeing in the soil is the net amount of carbon that's stored. So there's constantly new carbon being put in, and microorganisms are constantly using that carbon for as part of the global biogeochemical cycles that they drive. So there is constant carbon turnover. So anytime we measure carbon in the soil, we're just seeing that the net of that, those inputs and outputs. So what we're really trying to get a sense of, though, when I'm talking about how long it persists, are there certain practices that seem to allow it to become more stabilized or more persistent, in the sense of we talk about stabilization mechanisms in terms of physical protection. So things like how does the soil physically, the physical aggregates, protect the carbon from being decomposed by microorganisms or other types of organisms within the soil? Are there biochemical protections? So one way we might look at this then is, are we seeing greater accumulations of carbon under managed or tame pasture as opposed to native pasture, for example? And I don't know. That's a question we could ask. And sort of biochemically, are we seeing some differences in terms of what's present there? And also just the degree of microbial activity in under these different practices as well. Do we have a more diverse and active microbial community under grazing practice A versus B, for example?
And just to jump on the question, when we're talking about different grazing practices, we're talking about, whether it be like continual grazing or, mob grazing or different type of scenarios in terms of pasture management, correct?
Correct.
Okay. So just last one here. So bigger picture, what do you hope comes out of this research? Like, what would be some big wins or big takeaways from this research if all goes well?
So the first thing would be to actually have that comprehensive baseline carbon map for where we are right now, because you asked earlier, had anyone done this before? And the answer is no, right? We don't have that map right now that allows us to say, here's where we are at the moment, and really get a sense of that. And the reason that is so important is that we need to, if we don't know where we're starting, we don't know if we've actually made improvements. We don't know if we're making any types of enhancements. So, the same way that if I want to lose weight, I've got to step on a scale today, so I know if I weigh myself in a month, have I gained weight or lost weight, right? There's you have to have that starting point in order to be able to make that measurement. And so that's the one component of that. And then if we're successful, we'll also be able to determine, what do we need to be doing if we want to maximize our carbon storage? Can we detect changes associated with different management practices in these pasture lands? Are some practices more beneficial than others? So we can really help provide that insight to producers who are wanting to make sure that they've got the future of their healthy soil and longevity of their pasture in mind.
That was Angela Bedard-Hahn, a soil scientist and dean of the College of Agriculture and Bioresources at the University of Saskatchewan. Next up, dendroclimatology is a complex word, but it is fun to say. Dendroclimatology is a branch of science where researchers study tree rings to understand the climate on Earth 400, 600, or maybe 1,000 years ago. Recently, Geraldine Wichers, a reporter with the Manitoba Co-operator, learned more about dendroclimatology when she spoke with David Sauchin of the University of Regina.
Count a tree's rings and you'll know its age. We learned that as kids. But did you know that the rings can tell us if the tree lived through droughts, floods, and fires? Dr. David Sachin is the director of the Prairie Adaptation Research Collaborative, aka PARC, where he studies dendrochronology. Dendrochronology uses tree ring samples to reconstruct environmental conditions in the past. The distant past. We're talking 1,000 years ago, when the Europeans hadn't built weather stations on the prairies yet because they were too busy fighting the Vikings. Since tree rings are wider or thinner based on available water, Dr. Sachin has been able to build a 1,000-year timeline of prairie stream flows. I caught up with him over Zoom to ask him how the tree rings help us today. So you have this timeline that goes back to 888 for stream flows, I believe it was at Medicine Hat at the South Saskatchewan River. Where did you find trees that took you that far back?
Oh, well, there's trees in the foothills of the Rockies that are close to 1,000 years old. But we also use deadwood because trees die, and in some cases, they take hundreds of years before they rot and disappear, right? So if we find a tree that died, say, 300 years ago, and it was 800 years then it goes back 1,100 years, 800 plus 300, right? So the tree rings go back at least 1,000 years because the tree was 800 years old, but it died 300 years ago. So that's how we get these long records, is we keep looking for and finding these logs. And they're kind of hard to find because if a tree falls on soil, it's going to rot because there's water. So it has to be someplace where it's real dry, like a steep slope or a rocky soil or the tree falls on another tree and it's suspended above the ground. Because what causes wood to rot is wetting and dry, right? If you can keep wood dry, it will rot, which is why we protect the framing of our house with house wrap and siding and so on, keep it dry. Also, if you keep wood wet all the time, it won't rot. So if you scuba dive and haul a log out of a lake, it can be intact because it's been saturated all the time. And so we don't scuba dive, but we find wood at really dry sites. And that's how we get back to 888 so far.
So you showed us this timeline, and one of the things that you pointed out were these multiple decades-long droughts. But beyond that, what other insights does that timeline give you?
One of the major insights, well, first of all, like you said, it shows that it's possible for droughts to be more severe and longer than anything we've experienced, unless your family's indigenous, right? The rest of us have only been here for 140 years at most, and it just turns out the last 140 years there hasn't been a drought as long or severe as before that. That's not to downplay, say, the 1930s, because my grandparents had to relocate in the 30s due to drought. So I'm not dismissing the severity of the drought of the 30s and 80s and so on, but there just hasn't been a drought as severe as some of the droughts in the tree ring record. But a major insight is the cycles, how often these droughts reoccur. Now, if you're only talking about a 1-year drought, you can just look at the weather records and count the number of 1-year droughts and come up with a return period. But if you're talking about droughts that are 3 to 4 to 5 years in duration, there's only been 1 or 2 since the prairies were settled. In the tree rings, if you go back to 888, you just have a much bigger sample size. So we're much better able to estimate the return period or the frequency of droughts of a certain length or severity using the tree rings. And the more severe and longer the drought, the better able we are to estimate how often you would expect to see them. The other thing is the cycles. There's these natural cycles in our climate. There's the year-to-year cycle. We go, wet, dry, year to year. But there's also what we call a decadal cycle. There are periods of a decade or two that are relatively wet, and there are periods of a decade or two where it's relatively dry. And this is extremely important because people can confuse climate variability and climate change. So we could have a few drier decades and people say, oh, the future is going to be horribly dry because they're extrapolating from a couple decades to the end of the century. Well, no, that's part of a natural cycle, and we're going to come out of it, and we're going to have a few wet decades. The same thing, we could have a couple wetter decades and people say, oh, in the future, it's going to be horribly wet. No, you're extrapolating from the natural variability. You're confusing the natural variability with the climate change. You can look at what we've been through, the 80s, the late 70s, 80s, early 90s. There were a lot of dry years, not every year, but there was. And then we got into a period in which there was more wet years and dry years.
Mm-hmm.
Just so it's not as if we have an entire decade of drought or flooding, but there are decades in which we have more wet years and dry years. Mm-hmm. And the tree rings show that this is part of our natural variability of our climate.
Does the tree ring record tell you anything about climate change itself?
Good point. It tells us mostly about the natural variability, but if you go back far enough, you can see shifts in the natural variability. So if you go back far enough, you can see times when drought is much more common than excess water. And you can see times when excess water is much more common than drought. And if these periods are decades or centuries in length, they represent a climate change. And pre-industrial, like before the Industrial Revolution, these were natural shifts in the climate. Now we're in an era, or we're in a period of human history in which humans have modified the climate. So we would expect the anthropogenic climate change to show up in the tree rings. We don't see it yet. I don't think there's been enough anthropogenic climate change that it's detectable against the background of natural variability. And that's partly because on the prairies, our climate is so extremely variable that it's hard to see this incremental change in climate that we attribute to human activities. If we had a less variable climate, if we had a climate where we get more or less the same amount of precipitation every year, then it would be much easier to see the regional influence of global climate change.
Other metrics do show global warming, including models park researchers have built. However, Dr. Sachin said the tree rings aren't affected as much because warming is affecting prairie winters most, and during the winters, the trees aren't growing.
In a park, mostly what we use is data from models. Because we haven't found any trees from the future yet. The only way you can get information from the future is models. It's the only possibility. So all of our estimates of future climate change are from models. But the model climate isn't real, right? It hasn't occurred yet. It's hypothetical. The tree rings tell us what the climate is actually being. It's recorded in the trees. So we can test the models. We can evaluate our confidence in the models to see if they're actually able to replicate the past climate.
Sort of like running them backwards instead of forward?
Yeah. Because the climate modeling centers, they'll take their models and they'll run them starting in, say, the year 1850, right up to the end of this century. Well, we can use the section of the experiment from 1850 to now and say, well, how does that compare to the tree rings? And how does it compare to weather data, weather observations? Even some modeling centers will run their model for 1,000 years without any greenhouse gas forcing. In other words, they'll assume that people have no effect on the climate and they'll run it for 1,000 years. Well, we can compare that to what the tree rings tell us because the tree rings were around before the Industrial Revolution.
I asked Dr. Sachin, why should any of this matter to farmers?
I think some of their hesitation is whether they actually see the climate changing. And it's difficult to see because it's against a background of huge variability from season to season and year to year, right? You really have to stand back and look at, okay, yeah, you're right. I was farming 40, 50 years ago and the winters were much colder. So I'm sympathetic when they say they can't see climate change. But I guess what we emphasize is, we have no choice but to use models. We'd rather have data from the future, but we can't find it. So we have to use models. And these models are actually pretty good. They're able to replicate the climate of the past. And they really are they have the same physics as a weather model. So if you use weather forecasts, and if you believe the weather forecast, and most farmers do, they rely on the weather forecast. It's the same models that produce the weather forecast that produce the weather 30, 40, 50 years from now. We just can't verify it. I mean, if last night they said it would be -6 in Regina, it only got to -4. So we know it was off by 2 degrees. We can't do that for the 2050s. Well, maybe you will be able to say, oh, it's 2055. And that model back in 2022 was suggesting. We won't be around to know whether the model is correct. But these models are derived from weather models, and they're able to replicate the climate of the past, and it's all we got. But we also have other information from a whole network of weather stations, and we have the tree ring data. So we can sort of combine data that spans the past 1,000 years and the next 100 years and come up with scenarios of what we expect in the future. We don't call them predictions. We're not predicting the future. We can't possibly, but we can come up with estimates or scenarios of what we expect will happen. And we don't think that people are going to, based on a climate projection, they're going to change what they're doing, right? But when they get an opportunity to change, when they get an opportunity to try a new rotation or a new crop or a new implement, when they're changing for other reasons, they might want to consider whether it's a good idea given these climate projections.
You've been listening to David Sauchin, a tree ring expert at the University of Regina. Well, that's it for this week's show. I'm Robert Arnason of the Western Producer. Thanks for listening.
Maybe you've had an idea about upgrading your operation. Maybe about finally getting that renovation done or buying some new equipment. Or maybe you're thinking about how you can be a bit more financially secure from season to season. Get some help making it happen by speaking with an RBC Agriculture Account Manager. Then, set up an investment plan to make even more of your ideas happen. Visit rbc.com/chartyourcourse and get started today.